Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagmani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So in this present series of our database management system, we have started with the topic of database system architectures, and in our previous lectures we have seen what actually these database system architectures are and how are they are getting evolved, we can say, and what are the different list of the different database system architectures available, and within those within that list we have also seen the centralized systems which could be a single user system or it could be a multi user system in detail. Now starting from continuing further, today we are going to discuss various other database system architectures which are left in the list, and from there we are going to begin with client server system. So as the name indicates, client server system, it is actually in a typical system it is having one server and it could be M or N clients, and these clients are actually connected to the server through a cable whose through a connection, I can say. Cable could be an undermining word here. It could be a cable or it could be any other type of connection. So general structure is shown below. Here you can see that there are various clients and there is one server. So I am talking about a typical example of a client server system. Here if we can see both the entities, one is the client and another one is the server, are having their own designated roles, and these roles will be we can say cannot be swapped, cannot be changed. So one who is the client is going to start the request or going to request for the service, and one who is server, that means one who serves, is actually a system which is going to fulfill that particular request, and server will be server always and clients will be client always. They are having their designated roles. We have some systems in which this designated role of client and server can be reversed. So here I am not talking about those systems. So server system satisfies the request which is generated at the client system, and server system is there in order to serve all the client system which are connected to it. Now if we can see the functionality which is provided by these type of database systems can be broadly categorized into two categories. One is it could be a front end, we can say front end functionality, and another one is the back end functionality. So when I am talking about the front end functionality and back end functionality, the back end functionality is going to manage all the we can say access structures like various tables and indexes. The query evaluation part is also, we can say, is also to be managed by the backend. The optimization scenario is to be taken care of, and also the concurrency control and recovery part has to be we can say has to take place at the backend only. While when we talk about the front end, that front end of the database system is going to is actually an entity or is actually a platform. When we talk about front end, which is directly in front of, which is there directly in front of the user. So user is going to interact with a particular database. For example, there is a form interface. The user is going to fill some form and then going to deposit that. A report has to be generated as per the requirement of the user. It could be an SQL query or it could be any other kind of analysis. So the front end of the database system is going to consist of all those tools which are there to perform all those activities which are just elaborated. For example, in order to execute an SQL query, it should have SQL user interface. In order to access or update or insert or delete the data through a form, it should have form interfaces. Then if a report is to be generated, report generation tool is required. And apart from that, if you want some advanced kind of analysis and some data mining related activities. So these tools should also be there. So backend is going to take care of query evaluation, optimization, concurrency control, recovery, access structure, all these activities which are going behind the curtain, I can say, while the front end of the database system will provide the interface through which your user can interact with the database system. Now this interface between the front end and the back end could be through a particular application program or through a standard we can say a platform which is built in which is already built in, for example, kind of your structured query language. So any type of interface could be between the front end and the back end. So here if you can see in the figure we have the difference of the functionalities between the front end and the back end. At the back end you have an SQL engine who is responsible for this query optimization thing, for other functionalities related to backend, for example access to index structure and so on and so forth. And there are various front end facilities, for example SQL user interface, some form interface, some report generation tool. And in order to connect this front end functionalities and the backend functionalities which are available on the SQL engine, there is an SQL API, or it could be any other type of interface which could be through we can say a sophisticated application program also. So all these tools or all these interfaces which are given in the top of the figure belongs to the front end, while the SQL engine which is given at the bottom of the figure belongs to the backend. So here we can in this way we can say that we are able to divide the functionalities between front end and the backend, while the some transaction processing systems provides a transactional RPC, which is remote procedure call interface, in order to connect clients with a server. So if we talk about these kinds of remote procedure calls which are there to connect a client to a server, and all these are provided by a transaction processing system, these type of RPCs appear like ordinary procedure calls to the programmer, but these are actually kind of we can say remote procedure calls from a client which are enclosed in a single transaction at the server end. Now why they are enclosed in a single transaction at the server end? So if the transaction abort, the server can undo the effects of individual remote procedure calls, which is kind of we can say having enclosed in a single transaction at the server end. So if the transaction is going to abort, the server can undo the effects of individual remote procedure calls. Now initially when we talk about the earlier legacy database systems, there were the machines which are available for these kinds of database were actually kind of mainframes with the network of workstations or personal computers which are connected to backend server machines. So there are actually mainframe machines, could be one, or mainframe machines with the network of the workstations. These workstations could be PCs. So we have many PCs attached to that mainframe, and these are forming we can say the backend server machines. And now these actually have been replaced, because now even in the normal machines, I am not talking about the mainframes, we have better functionality as compared to the cost which we were investing in the mainframes. Then flexibility in locating resources and also the facilities of expansion. We can give better user interface, and we can also have easier maintenance. So maintenance of mainframes we can say which was available in the legacy systems were actually difficult. Now here we have seen in the previous lecture we have seen the centralized system, then we have client server system, we have seen the client server systems as well. Now when we talk about particularly the servers, which is about the server system architecture. Now what kind of architecture the servers are having? So server systems can be broadly categorized into two kinds. One is the transaction server and another one is the data server. So as the name indicates, transaction server are there to support the transactions or are there to execute the transactions, while your data servers are mostly used for kind of storage of data, we can say. When we talk about the usage, your transaction servers are widely used in relational database systems, while the data servers are used in object oriented database systems. So both transactional servers and data servers, they have their own we can say usage area or their own applications. So the transaction server systems are also known as query server systems, which are going to provide an interface to which clients can request a query, or clients can request to perform an action, and in response to which the action has been taken by the transaction server and the result has been sent back to the client. So when we talk about transaction server system, we are essentially talking about a query server system in which the query is being submitted through an interface by the client, and response is expected in the form of an action, and the result of that particular action is also being we can say conveyed to the client. And when we talk about the client machines, they are the machines who are going to request for a service to the server system. These are the machines who are going to give rise to the transactions, and they are waiting for the results to be shipped back to them. And the main, we can say, task of this client's machine is actually the display of data, we can say. And these requests, as I have told you, could be specified through an SQL API or something of that sort, or it could be a more sophisticated, more specialized application program interface also. So within this server system architecture, we have seen the one type of we can say we have gone through the details of the transaction server system. Now coming to the second kind of the server system, which is about the data server system. And as I have told you, this data server system is mostly in charge of the data. So it allows clients to interact with the servers by making requests to read or update the data. Generally in this kind of thing, we are not expecting any transaction to happen here. It is all about the data. It could be kind of update of data in units such as files or pages. So this data can be updated via file wise, we can say, or via page wise. So for example, when we talk about the file server, which is actually a type of data server, because it is storing the data in the form of the files. These file server provides a file system interface which through where a client can create, update, read or delete the files. Now apart from this, only we can say making the request to read or update data in terms of some units, for example creation of files, updation, reading or deletion of file. Your data servers for the database systems offer much more functionality. So not only the files but various units which are actually way smaller than a file are being supported. For example, it could be a page, it could be a tuple, or even it could be an object. And they provide indexing facilities for data and provide transaction facilities, so that the data is actually never left in an inconsistent state if a client machine or a process which is undergoing fails. So, if you can see till this point, we have seen the client server systems and we have also seen the server system architecture. The next which is coming up in the line of the database system architectures is the parallel systems. Now, when we talk about the parallel systems, that means there are multiple processors and multiple disks which are working in parallel. And why there is a requirement of these kinds of parallel systems is they improve processing and also the input output speeds. So, the speed of the whole system can be we can say increased by using the concept of parallelism. So, parallel machines are nowadays becoming more common because the study of parallel database system is considerably getting more and more importance in research. Also, your hardware, if we can see, is getting cheaper day by day. So, parallel systems are coming we can say more coming more into effect, getting more popular. Now, what is the driving force behind these parallel systems is we have large database, huge databases nowadays. Let's say order of terabytes, that is 101 10 to the power 12 bytes. So, 10 to the power 12 bytes or terabytes or something of that sort if I am talking about, we need a machine which is extremely fast. That means that machine should be able to handle number of transactions per second should be of order of thousands. So, then in that type of situation there is one machine is not able to cope up with these kinds of huge technical requirements. So, this is actually working as the driving force or as the initiating reason behind the parallel database systems. And these because when we talk about these type of requirements in which the databases of order of terabytes and number of transactions per second we require, that is in the order of thousands, the normal centralized and the client server database systems are actually not powerful enough to handle these type of huge technical specification applications with huge technical specifications. Also here the parallel database systems are consist of multiple processors, as I have already told you, and multiple disks also, and these multiple processors and multiple disks are connected by a fast interconnection network. And what could be that interconnection network? That entirely depends upon how geographically distant these machines are we can say put in. Now, when we talk about parallel systems, there can be two type of parallel systems. One is coarse grain parallel system, another one is a fine grain parallel systems. Fine grain parallel system is also known as massively parallel system. So, a coarse grain parallel system consists of a small number of powerful processors, while the fine grain parallel machines utilize thousands of smaller processors. So, here we have in one we have normal kind of processors, but the number is more, and in the coarse grain we have the small number of processors, but they are way more powerful than what actually a normal we can say machine do we have. Now, when we talk about parallel performance, parallel database system architectures, what are we actually looking into? As we have seen that we are looking for we can say speed. So, here the two main parameters which are which comes into the picture for performance measure are one is the throughput, another one is the response time. So, throughput, as you know, that the number of tasks that can be completed in a given interval time is known as throughput, and response time is the amount of time that it takes to complete a single task from the time it is submitted. So whenever a particular task is being submitted, that particular timestamp is being subtracted from the timestamp which is in which the task is being completed. So the duration of the task from submission to completion is actually the response time. These are the two main performance measure. So right from whenever we have started with database system architecture, we have seen centralized systems, we have client server system, we have gone deep into the specifics of server system architectures, and we have also tried to explore the parallel performance, the parallel database systems. What is left is actually your network types. So network types is actually when we are the term network indicates that the machines are connected to one another using a common connection, and these machines are here we can say these are the machines which are having different database systems, or these are we can say are the database systems. So here in this network types we can have three types of database system architecture. One is the bus system architecture, another one is the mesh system architecture, and the third one is the hypercube system architecture. So bus system architecture, this is we can say is actually a concept which is borrowed from computer system architecture. It is system in which various components sends the data, receives the data through a common single communication bus as it is shown in the figure. So here is a bus which is the line connecting all the systems or all the we can say machines. But what is the problem with this type of network of databases is it does not scale well with the increasing parallelism. So for example, if we are going to increase the parallelism and then we are going to increase this these machines and the bus in a linear fashion, so this does not perform well in along with the scalability we can say. Next, and there are also various other advantages as well as disadvantages of this type of network system, and for the more details of bus network system, I would suggest you people to refer to any networking course. So you will be having a fair idea about the this kind of structure I can say, which is more commonly known as topology in a network system. So when we talk about the next one, which is the mesh system database system architecture, in which mesh, so the mesh means here is a kind of net, a closed net, or we can say a grid. So in this, components are arranged as nodes in the grid, as you can see. For the simple structure, for the sake of simplicity, I have shown it in the form of a matrix, 3 by 3 matrix. All the intersection points are machines, and each component is connected to all the adjacent components by one or the another kind of we can say line or connection. And as as we are going to increase the number of components, the communication lines will obviously grow with the growing number of components. So we can say yes, it scales better, but it is having its own disadvantages we can say. So disadvantages means so for example it could be fault diagnosis is a little bit trickier, but yes, in terms of reliability this is more the way more reliable than any other kind of structure, but this is complicated and needs more hardware. And also in order to in this type of a grid which I have just shown you in the on the screen, so it may require 2 root n hops to send a message to a node where root n is we can say a wraparound connections at the each edge of the grid. So mesh structure is also having its own advantages and disadvantages. The third one, which is kind of common in when we look into the database system architectures, is actually the system architecture named as hypercube. So hypercube, if you see, hypercube is shown here in the figure, and the components are numbered in binary. So we have 000, then we have 001, then we have 011, we have also 010 on the left wall of this particular cube, I can say, and there are others. So each and every component is being numbered in the binary, and these components are connected to one another if their binary representation differ in exactly 1 bit. So for example, there is a direct link between 000 and 010 because there is just the difference of 1 bit. Then there is a connection between 000 and 001, again the difference of just 1 bit. So there is a connection, and so on and so forth. So the components are connected to one another if their binary representations differ in exactly 1 bit. And here, if you can see it kind of very carefully, we can say that n components are connected to log n other components, and the message which is being sent from one particular component to others can reach to others via at most log n links, and hence it also reduces communication delays. So here we have seen the hypercube thing. Before that we have seen the mesh structure and the bus structure as well, and I have also covered a couple of, we can say, advantages and disadvantages or scenarios in which they are going to be useful. So in this lecture we have started from client server system. After understanding the concept of client server database system, we have gone through the server system architecture into more details, and there we have seen couple of server system architectures. Then we get into the parallel system. We have seen the need, we have seen the issues, and what kind of two types of parallel systems are there. One which is more number of the processors but with the normal power, other which is having less number of processors but they are powerful processors. And then after that after that particular parallel systems study, we have gone into what all kind of network types could be there when we are talking with reference to the database system architectures. And this actually completes our topics of database system architecture. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed the lecture. I'll see you in the next one. Till then, take care. Goodbye.